So today we're going to unpack something that feels like it's been pulled straight out of science fiction. We're talking about Google DeepMind's Gemini 1.5, an AI model with a memory so huge it kind of changes the game. And to really get a handle on just how big a deal this is, let's kick things off with an analogy.
I mean, that just perfectly nails it, right? We're not just talking about storing a bunch of information. We're talking about understanding and recalling one single tiny detail from an absolute ocean of data. So how on earth is that even possible?
All right, so here's how we're going to break it all down. First, we'll tackle that seemingly impossible memory. Then we'll get into the tech that makes it happen, look at the proof, see what it can actually do in the real world, and finally, take a peek at what's coming next.
Okay, let's dive right into the core problem here. For years, the big challenge with AI was this trade-off. You could have a huge memory, or you could have a precise one, but you couldn't really have both. Finding one specific detail in a vast sea of information, that's been a massive hurdle. Well, until now.
Well, the secret is all about this thing called a context window. You can basically think of it as an AI's short-term memory, how much info it can juggle at once. And with Gemini 1.5, they didn't just widen that window, they blew the doors clean off.
And here it is, the headline number, 10 million tokens. It's a number that's genuinely hard to wrap your head around, because this isn't just a small step up. It's a generational leap that completely redefines the scale of what an AI can process in one single go.
And this chart, wow, it just lays it all out, doesn't it? You see GPT-4 Turbo way down there at 128,000 tokens, Claude 3 at 200,000, and hey, those are impressive numbers. But then you look over at Gemini 1.5 Pro, and it's not even in the same league. It's a whole different sport. That's a 70 times increase over its main competitor.
But what does 10 million tokens even mean in the real world? Well, think about it like this. It's like handing an AI 10.5 hours of video, or almost 5 straight days of audio, a massive software project, or a stack of 70 novels and saying, here, analyze all of this at once. It's just incredible.
Now, you might be thinking that processing all that data must take a truly insane amount of computing power. And honestly, you'd be right, if not for a really clever design running under the hood. So let's get into the secret sauce that makes all this possible.
So that secret sauce? It's called Mixture of Experts, or MOE for short. And the best way to think about it is right there in the name. Instead of one giant generalist brain trying to solve every single problem, imagine a team of specialists. When a problem comes in, only the most relevant experts, say the code expert or the vision expert, actually get to work.
It's a simple but brilliant 3-step process. First, your query comes in. Could be text, video, whatever. Second, the system acts like a super smart switchboard, routing your task to only the small handful of experts that are best suited for the job. And finally, those experts work together to give you an answer. It's efficient and it's powerful.
So what's the payoff for this clever design? Well, you get 3 huge wins. It is wildly more efficient, which is how it handles that massive context window. You get better results because specialists are on the job. And believe it or not, it's actually faster to train in the first place.
Okay, so the theory sounds great, right? A massive context window, a super efficient architecture. But does it actually work? Can it really find that one tiny detail in a mountain of information? Well, researchers designed the perfect test for exactly that. They call it the needle in a haystack test, and it's pretty much exactly what it sounds like. You hide a specific piece of info, the needle, somewhere inside millions of tokens of random data, the haystack, and then you just ask the AI to go find it. Simple, right? And the results? Honestly, they are just staggering. When they tested it with 1 million tokens of text, it found that needle with 99.7% accuracy. How about audio? They hit a secret keyword somewhere inside 107 hours of recordings. Its recall? Perfect, 100%. And even when they pushed it to the absolute limit, the full 10 million token context, its accuracy barely budged, staying at an incredible 99.2%.
And to really put that in perspective, you have to look at what other models do. Something like GPT-4 Turbo starts to see its performance just fall apart at its max, dropping to around 50% recall. But Gemini 1.5? It stays rock solid and reliable, even at these extreme scales.
Okay, this is all incredibly cool from a technical standpoint. But what does it actually mean? What new superpowers does this kind of thing unlock for us in the real world?
Well, for starters, if you're a developer, this is an absolute game changer. You can literally feed it an entire software codebase, in this case, almost 750,000 tokens of code, and just ask it to find one specific thing, and it just does it.
Okay, this next one is just wild. Researchers gave the AI a grammar manual for Kalamang, a language with fewer than 200 speakers in the world. And just from that book, it learned the language well enough to translate sentences basically at the same level as a human student. It learned a language on the fly. And get this, it's not just about text or code. It can reason across different kinds of media. In one test, they showed it a simple, hand-drawn sketch and asked it to find the matching scene in a 45-minute silent movie. And not only did it find the scene, it gave them the exact timestamp.
So, what we're really seeing here isn't just a simple upgrade. It's a fundamental shift. We're stepping into a new era where AI can hold a continuous, deep understanding of, well, of pretty much anything you give it.
And the best part? This isn't just some far-off research project. Google is already working to make this power more accessible with things like Gemini 1.5 Flash, a lighter, faster version designed to bring these memory superpowers into the everyday apps we all use.
And that leaves us with a really fascinating question to think about. For the first time, we're building tools that have a nearly perfect, practically limitless memory. As that power becomes more and more common, the most important question we're going to have to answer is, what should we ask it to remember?